everyone, welcome back to my channel Infinity Plus. Today we are learning about the most important topic, that is matrices. You might have already known what the matrices are, but in this video you are going to learn the most important applications of matrices. So let's dwell into the topic where matrices are used and why they are so important. Matrices are used to simplify the work. They are used to provide simple methods to solve linear systematic equations. It's not only about linear systematic equation, but also they are used in many other forms, such as if you take up, it's used in electronic spreadsheets, data analysis, and also analyzing the results of some experiments and budgeting and much more. If you are finding the basic concepts of matrices, so let's understand what is the matrices really mean. So let's define what are matrices. Matrices are ordered rectangular arrangement of numbers and functions in terms of rows and columns. So first dwell into the words which they have given in this definition. Why it is a rectangular arrangement? If you take up the rows and columns, it will form either a rectangle or it will form a square. So take up an example. I am taking a matrix A. We can tell that matrices are always represented with a capital letter. So you can remember this word. Matrices are always represented with a capital letter. So if you take up these examples, I have represented this matrix in terms of numbers. If you take up another example, so take it as 1x x square, 2x 2x. This is a matrix which is consist of both numbers as well as the functions. So any matrix which includes both numbers as well as the functions. Numbers and functions inside these matrices, they can call it as the elements of a matrices. So let's understand what rows and columns of these matrices literally means. I'll take up that example which I have taken earlier as it is. A is equal to 1, 2, 3, 4, 5 and 6. The horizontal lines which are formed in a matrix, these horizontal lines are called as rows. So this is the row 1 and this one is the row 2. And the vertical lines which are formed in these matrices, they are called it as columns. So I will be having in an example, this is the C1 and this is C2 and this one is the C3. So this represents the rows and columns of a matrices. So now let us understand what is the size of a matrix. If we move on to size of a matrix, it is said to be as the order of a matrix, which is also called as size of a matrix. If I take up the size of a matrix, take an example which I have taken earlier. So I am taking matrix A as it is, which will be A is equal to 1, 2, 3, 4, 5 and 6. So this is the matrices which I have taken earlier. So if I take up this one, how many rows are there in this matrix? It is row 1 and row 2. So how many rows are there? 2 rows are there. And how many columns are there? As I have said earlier, there are 3 columns are there in this matrices. So it will become cross 3. So order of a matrix is represented as number of rows and columns present in the matrix. So you might have cleared about the idea what is the order of a matrix or the size of a matrix. It's represent literally the number of rows and columns present in the matrices. So let's move on to the types of matrices. Among type of a matrices, first will be the row matrix. If you take up row matrix, what is row matrix? Row matrix is any matrix which is having only one row. Any matrix having only one row. So can you guess the example? What will be the row matrix example? Yes, take it as any row. You can give whatever you want. 1x x square, or you can also give 1 sin x cos x, and you can also give any number -1 0 2. So these are some of the examples of a row matrices. So next move on to the column matrix. What is column matrix? Column matrix is nothing but any matrix which is having only one column. Example of a column matrix can also be like, I am converting these row matrix in terms of column matrix. 1x x square, and if you take up the numbers, I'll get it as -1 0 5. So these are the few examples of a column matrix. So let's the next type is square matrix. You have already understood what is the matrix. Matrix is a rectangular arrangement. There you have studied rectangular arrangement. Then how come it will be a square? So let's understand how a rectangular matrix will get converted into a square matrix. So consider I am taking a general matrix of order m cross n. Means any matrix, consider it's having m number of rows and it's having n number of columns. If you have taken m cross n matrix, if I am getting that number of rows in a matrix is equal to number of columns, then you will get m is equal to n. So this is the condition for any matrix to become a square matrix. So any matrix which having equal number of rows and columns, it is said to be square matrix. So you have understood a square matrix. So look at some of the example of a square matrix. So I will take up the word simple matrix 1 cross 1. If I am taking 1 cross 1, it should have one row and one column. So A is equal to, I will take up 1 as an example. So it is having one row and it's having one column. So this is a square matrix of order 1 cross 1. So take up the square another matrix of order 2 cross 2. So A is equal to, take up any example 1 0 0 2. So you will be having number of rows in this matrix as R1 R2 and number of columns in this matrix as C1 and C2. So means you will be having 2 rows and 2 columns. So in a similar manner 3 cross 3 will become 3 number of rows and 3 number of columns. So let's dwell into the next type of a matrix. So next type of a matrix is a diagonal matrix. If you have taken the diagonal matrix, it is a square matrix where the non-diagonal elements of a matrix are 0. So let's understand this diagonal matrix with an example. So example I have taken it as A is equal to 1 0 0 0 5 0 and 0 0 minus 2. You can observe one thing in this matrix, that these diagonal elements which I am having here, they are not equal to 0, and apart from diagonal elements, whatever the elements you are having, it's equal to 0. So such kind of a matrix is referred to as a diagonal matrix. Can you give me an example of a diagonal matrix apart from this matrix? Okay. So next type of a matrix is a scalar matrix. If you have taken up the scalar matrix, you must be well known with the diagonal matrix. Scalar matrix is nothing but a diagonal matrix where the diagonal elements are same. Diagonal elements will become equal to each other. So let's understand with an example. If I take up an example, so let's convert this diagonal matrix into a scalar matrix. So I will be taking A is equal to, so scalar matrix is represented as, it is a diagonal matrix where the diagonal elements are same or they are equal to each other, and non-diagonal elements are equal to 0. So next type of a matrix is identity matrix. If you have learned a bit about the matrices, you people are well known with the importance of this identity matrix. So let's define what is identity matrix. Identity matrix, I'll take it as a scalar matrix where diagonal elements are equal to 1. So take up the example as 1 0 0 0 1 0 0 0 1. I have taken the identity matrix of order 3 cross 3. So last but not the least, let's learn the most important other type of a matrices. Yes, it is a zero matrix. Any matrix where all the elements should be equal to 0. Take up an example. I am taking the 2 cross 2 matrix. I'll take it as 0 0 0 0. And we'll just take up the quick revision for whatever the things we have done in this video. So just we have defined what are matrices and some of the examples of a matrices, and we have understood the elements of a matrix, which what are rows and what are the columns. We have understood the order of a matrix with the representation of order of a matrix. We have understood different types of matrices. First one is the row matrix, which is having only one row, and another one is the column matrix, which is having only one column. Next is square matrix, where the number of rows are equal to the number of columns, and this is the condition which is very important for the square matrix, because it has been asked many times in the CT exams and all. So please do remember this condition for the square matrix. And next one is the diagonal matrix, where the diagonal elements are not zero. Next is the scalar matrix, where diagonal elements are same. Identity matrix, where the diagonal elements are equal to 1. And last one is the zero matrix, where all the number of elements of a matrices are equal to 0. And that's it for today. Introducing into the matrices, we converted definition of a matrices, determined its order, and we have learned different types of matrices. You make sure that you'll hit the like button if you found this helpful. Please subscribe to my channel for more exciting maths lessons. See you in the next video, where we'll dive deeper into the world of matrices.